This is a little review for the area charts and rates quiz. So we have letter A. Well, let's read it first. Let R be the region bounded by the graphs of y equals sine of pi x. So here's the sine of pi x. It's the top. So that's the top function. And y equals x to the third. That's the bottom function, as shown in the figure above. Let's grab a calculator here. Find the area of R. So the area is top minus bottom. So we're going to integrate from 0 to 2 of the top, which is sine of pi x minus the bottom, x to the third minus 4x dx. So math number, let's turn it on. Math number 9, 0 to 2 of sine of, not alpha, pi x, and then we're going to subtract in parentheses x to the third minus 4x dx. And we get 4.109, I guess we can have. So letter B. The horizontal line y equals -2 splits the region R into two parts. Right, but do not evaluate an integral expression for the area of the part of R that is below the horizontal line. So y equals -2. We're going to need these two intersection points. So let's get the x to the third in the calculator. X to the third minus 4x and -2. And let's go zoom 6. And I suppose we could have put, 0 to 2 and -3 to 1 would have been fine as well. But all I really need is the intersection points is what we're looking for. So first curve, second curve, guess. So we're going to integrate from 0.539188887 to, let's get the other one. Calculate number 5. Enter. 1.6751309. And we still need top minus bottom. So -2 minus x to the third minus 4x dx. Let us see the region R is the base of a solid. For the solid, each cross section perpendicular to the x-axis is a square. Find the volume of the solid. We're going to integrate from 0 to 2 of side squared is really what we want. But the side is between, all the sides are between the two curves. So we need top minus bottom, and then we need to square that. So sine of pi x minus x to the third minus 4x squared dx. We're going to enter that into our calculator. I'm going to cheat, make this go a little quicker for you. 9.978. Letter D, the region R models the surface of a small pond at all points in R at a distance x from the y-axis. The depth of the water is given by, so this is our third dimension, depth. Find the volume of the water in the pond. We're going to integrate from 0 to 2. Here's the depth, 3 minus x, and then if you multiply that times the two-dimensional area, you get the third dimension. X to the third minus 4x dx. So there's the 3 minus x. This is the depth. And times area will give you the third dimension. So 8.369 or 8.370. Let's clear this and go over it. Concert tickets went on sale at noon. T equals 0, so this is noon. And were sold out within 9 hours. The number of people waiting in line to purchase tickets at time t is modeled by a twice differentiable function L for 0 to 9. Values of L of t at various times t are shown in the table above. So let's take a look at A. Use the data in the table to estimate the rate at which the number of people waiting in line was changing at 5:30 p.m., or t equals 5.5. Show the computations that lead to your answer and indicate units of measurement. So 5:30 is somewhere in here. So we need 150 minus 126 over 7 minus 4. That's going to be 24 over 3, so 8 people per hour. Indicate measure, show the kind. I think I got it all. B, use a trapezoidal sum with 3 subintervals to estimate the average number of people waiting in line during the first 4 hours that tickets were available. Well, L of t is number of people, so we want the average value. So we have 1 over 9 minus 0 times the integral from 0 to 9 of L of t dt is equal to 1/9 times 1/2. Now here's the trapezoids. First 4 hours. All right, so that has to be, these are all going to be 4s. First 4 hours. And 0 to 4. 1/2 times from 0 to 1 is 1. So our first trapezoid has a height of 1. Then 120 plus 156. Then plus 1/2 times 1 to 3 is 2 units. And that's 156 plus 176. 176. And then plus 3 to 4 is 1. So 1/2 times 1, and then 176 to 126. Should we just cheat? So there's the 1/4. There's all the values. So 155.25. 155.25. And what is the average people? Is the label. So letter C. For 0 to 9, what is the fewest number of times at which L of t must equal 0? L prime of t must equal 0. Give a reason for your answer. So L prime of t changes signs between, let's see, from 120 to 156, that's increasing, still increasing, and then decreasing. So between t equals 3 and t equals 4. Between, now we're, let's see, decrease went right back to increasing. T equals 4 and t equals 7. And we can say between, I think there's one more. 126 to 150 is increasing and then back down to 80. So between t equals 7 and t equals 8. So by intermediate value theorem, L prime of t equals 0 at least 3 times. At least. Could be more, but we know at least 3 times. D, the rate at which tickets were sold for 0 to 9 is modeled by this function, tickets per hour. Based on the model, how many tickets were sold by 3 p.m.? Well, we're starting at noon, so 0 to 3 of 550 t e to the negative t over 2 dt. And that's equal to 973. So 973 tickets. There we go. Let's see what else we have. What is the shape of the tangent to the curve? What is the slope? I think I said shape. Slope of the tangent to the curve when y equals 2. So the derivative is 2x first times the derivative of the second. It's going to be plus the second times the derivative of the first, but the derivative of the first is negative 2. So minus 2y minus dy dx is equal to 0. So let's factor out a dy dx, and we get negative 2x minus 1. The minus 1 is actually right there. And let's get all the other stuff to the other side. So 2y minus 2x. dy dx is 2y minus 2x over negative 2x minus 1. Now we're going to evaluate that when y is 2, but we need to know the x. Let's plug 2 in for y over here. We get x squared minus 4x minus 2 is equal to 3. So x squared minus 4x minus 5 is equal to 0. X minus 5, x plus 1 is 0. So 5 and negative 1. So how about 5, 2? So 4 minus 10 over negative 10 minus 1. So negative 6 over negative 11. So 6 elevenths, and then we'll evaluate at negative 1, 2. 4 plus 2 over 2 minus 1. So 6 over 1, 6. Evaluate. Well, we can let u equal sine of x. Du is equal to cosine of x dx. So that means we're integrating from 0 to pi over 2 of e to the u du, because cosine dx is du and sine of x is u. So that's integral of e to the u is e to the u. So that's e to the sine of x from 0 to pi over 2. So we have e sine of pi over 2 minus e to the sine of 0. And the sine of pi over 2 is 1, so we have e minus sine of 0 is 0, e to the 0 is 1, so e minus 1. Let's let u equal x over 3. So that 3u is x, and 3 du is just simply dx. So we have 3 integral. We're going to make dx into 3 du. And then x squared is, well, if we plug 3u in for x, we get 1 over 9u squared plus 9. That's really what we wanted, so we can factor out a 9. So 3/9 is 1/3, 1 over u squared plus 1 du. That's 1/3 inverse tangent of u, but u is x over 3. Where does f of x equal 3x squared plus 4x increase f prime of x? Let's try that again. F prime of x is equal to 6x plus 4. Set that equal to 0. So x is equal to negative 2/3, right? Minus 4 divided by 6. So negative 2/3. So we need negative 1. So if I plug negative 1 in the derivative, that's negative. That's decreasing. And then if I plug 0 in, 0 plus 4 is 4. That's positive. So we're increasing. Increasing from negative 2/3 to infinity.